So today we are going to talk about the fundamentals of two-way damage, what exactly it is, and what is the consequences, how it is getting done, and what are the remedial measures. So as the very first slide shows that few tuyers are burned with the particularly top edge, bottom edge, and the front part. So on the very right side, as you can see, especially one diagram I have kept for a common operators, that when we say that our silicon is less, so cohesive zone is at a very shorter height, that is very near to Tuyer, and chances of burning of Tuyer is increases. Similarly, when our cohesive zone lift up, that means silicon is high, and if we corroborate like this, that silicon and height of the cohesive zone, then it is more safer in the second case. Similarly, on the left hand side, the quality of the slag, actually this quality of the slag which gives you a confidence that what sort of bottom evacuation is there. That is, if slag is not good, not fluid, then level of metal and slag goes on rise and can touch the tuyer very easily, and it gets damage. So primarily I try to show off these majorly two things which on day to day basis it's happening. Now proceeding to our further part, uh, as an introduction, I just again want to capture a few bullet lines that tuyer burnout is a major disaster for the blast furnace, and it kills the process pot, especially when the bigger furnaces, two years, those who are double chambered, and body gets damaged in that type of situation, immediately furnaces to shut down. Of course, if nose gets damaged, then there is a chances that we can shift our immediate outrages or stoppages, and when some future prospects for shutdown observe, at that time we can convert those opportunity in terms of shutdown and change the nose or change the 2 years. But overall we can say that conclusion is that 2 year damage is nothing but it's a big loss for the operator, for the company, for the blast furnace process, for the production part, and it's also especially a big a is basically also a financial losses immediately. So coming to the common failures like melting, welding, abrasion, and buckling are the major, and few industrial statistics also taken from the other companies, which are being shared in the slides. These are the basically different type of activities in the operation or process which can break the 2 year. So coming to the warning of the 2 year, we can say the slag skin fall off, that is peeling of the slag also is many times is the reason of such type of activity. Of course, reasons are many, but today primarily we are going to take a note on particular this slide, because coke quality and the evacuation method, these two things are very important, because if coke quality is not good, coke gets crushed, then the voids which are getting hold by the metal and slag get filled up, as it is shown here by encircling a red mark, a red circle. So here we can see that, especially so I can show you, uh, So here we can see that as many pieces of the cokes are there, and whatever the gap is there, this gap is occupied by metal and slag. So if this coke cannot able to sustain the strength in this region where two things are there, it is under a huge load, and second thing, it is under a tremendous temperature. So if cokes can able to sustain such thing and retain its shape, then metal and slag will hold within these spaces, and there is no chances of immediately rushing this metal to this to your bottom. But if this coke gets crushed, then there is a always chance that metal and slag will be displaced from this place, and automatically this level will rise and bottom part of the tuyer will get damaged. So this is what is not expected, and hence operator must have to aim a best quality of coke, or whatever the coke norms is there. There should not be deviation. You must have to keep on monitoring the coke parameters on day to day, shift to shift basis, and to see also that what about the bottom differentials. And of course we can see those DCI's values or the alkali's load, because even though our coke textures is good, if alkali load will be there in the bottom, or we can say if alkali retention is there, then coke fragmentation, coke automatically will be lose its texture due to this alkali influence. And similarly this temperature also is to be monitored, your hearth pad temperatures, as because it also corroborate about your central column of the coke, what sort of temperature it has. So the hearth pad central temperature also gives you a lot of indication about your this coke column. Secondly, the quality of this metal and slag, it should be enough fluid and less viscous. And the third is most important is the taphole through which we are going to evacuate. It should have a good taphole length. Otherwise, siphoning of the entire melt out will be not there. Something will be retained here, and there is always a chances that once holding is increases here, then there is a chances that metal and slag level can touch this bottom part of the tuyer very easily. Hence, it is essential that here we must have to focus our three parts. First is the coke quality, and the second is the taphole, for taphole length, for this taphole clay qualities, the equipments that is getting used to apply this taphole should be functioning properly, ram speed, hydraulic pressures, and the operations is perfect in order to obtain the best out of your taphole clay. And third, I will say that the metal and slag quality with the proper temperature and viscosity is must. Apart from that, as I have discussed, your DCA and alkali load is must to be monitored apart from your center pad temperature, which also gives you the center column of the coke, what sort of thermal regime is there of coke column that we can able to get. So these all gives you a healthy condition of your and again it is about a accumulation. And as you must be knowing, accumulation, as we have already discussed, for accumulation we have already sorted out these five items, but primarily, as I say, that tap in efficiency and coke qualities are a big reason, big reasons to convert your operation into disaster, like to your boarding, etc. So here all those five reasons have been sorted out, uh, and as here also it is taken away. And one thing is that if the hearth itself is gets mug up, or getting freeze partially or gets dirty. In order to make it fluid, what is to be done? And for that, we have a two practices, but fluorospar practices is not recommended because as it is creating a lot of tear damages. Manganese ore is a better preposition, but we must have to keep ourselves away from all such type of activities. But ultimately, if things occur, then we must have to apply, and for that, this should be the regime in order to hold manganese recovery up to optimum, and for that, regime should be around zero point 0.7, zero point 0.8 silicon. And this is all about your diagnostic part, where we can also analyze our CO2 cups after before the hearth accumulation and after hearth rectification, what is the profile is there. So this is basically a cross check for the operator, as this is very important also factor, that how zinc is also creating a lot of problem for the tuyer burning, and this is a sort of a sources for the zinc, as the phenomena has been already elaborated in my previous presentation. I also taken this aspect, so I am not going to consume your costly time, and we can simply go through the slide, and if required, we can follow our zinc mechanism, how it damages the tuers. But just I want to keep all those information compiled to a single place, so then all my blast furnace friends can able to get all this information at a single point. So this is all about this findings of the two-year damage, and later on, if any clarification will be there, I think I will